Good morning, students. This is Pramod Joy, your computer science teacher. And this week we are going to deal with functions. What is a function? How to create functions? How to execute functions, etc. So, starting from the definition of the functions. A function is a subprogram that acts on data and often returns a value. Or, in other words, we can say that a function is a named unit of a group of program statements. One more definition. A large program is broken down into smaller units known as function. Or in other words, a function is a subprogram to do a specific task. Now the advantages of functions. Why we are using the function? What's the need of a function? If you are using a function in a program, it helps us to make the program handling easier, to reduce the size of a program, to make a program more readable and understandable to a programmer. Python function types. The functions can be classified mainly into three, and they are built-in functions, functions defined in modules, and user-defined functions. The first two we already explained in 11th standard. Like built-in function, you can see the examples, length, type, etc. Functions defined in modules, for example, in the math, you can see that sine or a square root, etc. And now here we are going to discuss about the user-defined functions, how to create user-defined functions. Now some of the important points related with the function. The very first point, a function definition defines a user-defined object function. The function definition does not execute the function body. This gets executed only when the function is called or invoked. You know that Python is an object-oriented programming language. And object-oriented programming language, the speciality of the object-oriented programming language is it employs a bottom-up approach. That means when you write an Python program, all the user-defined functions are written first. You have to write all the user-defined functions first. Only after that the main function, that means the main program. That means the main program will always be at the bottom. A function ends with a return statement or the last statement of the function body. A function ends with a return statements. I say this point with some reservations because we can use functions even without the help of that return statement. I repeat, a function ends with a return statement or the last statement of the function body. I told you with some reservations I am using that statement. In a Python program, generally, all function definitions are given at the top, followed by statements which are not part of any functions. The flow of execution refers to the order in which statements are executed during a program run. Values can be passed to a function. Python refers to the values being passed as arguments and values being received in the function definition as parameters. We can see the examples later. Arguments are also known as actual parameters or actual arguments. Parameters are also known as formal parameters or formal arguments. A function can be called using two methods, call by value and call by reference. In call by value, the called function makes a separate copy of passed values and then works with them. So original values remain unchanged. That means what all changes you are making in the function, it will be there only in the function. The effect will be there only in the function, not in the main program. But in call by reference, the called function works with original values passed to it. Thus, any changes made takes place in original values only. That means if you change any variable, any value in the function, it is affected everywhere. In Python, immutable types implement call by value mechanism and mutable types implement call by reference mechanism. Mutable types, list and dictionary. when the function call statement must match the number and order of arguments as defined in the function definition. This is called positional argument matching. Python allows us to assign default values to a function's parameters. A parameter having default value in the function header is known as default parameter. Non-default arguments cannot follow default arguments. That means whenever there is a default arguments, it should be written at the end, at the last. A parameter having a default value in the function header becomes optional in function call. Function call may or may not have value for it. That means while calling the function, it is not necessary to give any value to a default value. That means any value to a default parameter. In a function header, any parameter cannot have a default value unless all parameters appearing on its right have their default values. The default values for parameters are considered only if no value is provided for that parameter in the function call statement. Keyword arguments are the named arguments with assigned values being passed in the function call statement. An example is given below. They are called keyword arguments. Having a positional arguments after keyword arguments will result into error. Functions returning a value are also known as fruitful functions. The functions that perform some action or do some work but do not return any computed value or final value to the caller are called void functions. A void function may or may not have a return statement. A void function, or otherwise known as non-fruitful function, return legal empty value of Python, that is none. An example is given below. You can see that a function is defined called replicate to print $3. Below that the main program. In that main program only one statement is there, that is print replicate. It's not just a replicate but print replicate. Actually only replicate is needed. But here it is written print replicate. And now we can see the output. So that for the compiler will execute that main program first. That means print replicate. And first it will execute the replicate first, since that is within the bracket. So what's the answer for the replicate? Replicate is a function call. So suddenly that function definition will get activated. And what is the defined replicate? To print $3. So it will output, you can see the output, $3. But this replicate function is inside a print statement. So what is print replicate? The answer will be none. For replicate, you will get the output $$. But for print replicate, it will be none. Python allows you to return multiple values. Normally, in a function, or a function can return only one value. When you check the case of a C++ or a Java program or whatever be the programming languages, it can return only one value. And this is the speciality of that Python. It can return multiple values. For example, the first example defines squared of xyz. That's a function definition. And return x into x, comma, y into y, comma, z into z. And now the main program. What is the main program? T is equal to, a variable t is equal to squared of 234. So 2 stands for x, 3 stands for y, and 4 stands for z. So when you call a function, the function definition will be executed. So it will return x into x, y into y, z into z. That means 2 into 2, 3 into 3, 4 into 4. That all will be stored in t. And print t. That means when you print t, you will get the answer 4, 9 and 16. The same example written in a different manner. That is example number 2. Again the same function. Define squared of xyz. Return x into x, y into y, z into z. But here instead of just one variable, we are using three variables. V1, V2, V3 is equal to square of 2, 3, 4. What's the meaning of that? V1 is equal to square of 2 and V2 is equal to square of 3 and V3 is equal to square of 4. Now print V1, V2, V3. You will get the same result. A global variable is a variable defined in the main program. Such variables are said to have global scope. That means a global reach is there. A local variable is a variable defined within a function. Such variables are said to have local scope. That means that is confined within that function. Variables defined outside all functions are global variables. The lifetime of a variable is the time for which a variable lives in memory. For global variables, the lifetime is the entire program run. And for local variables, lifetime is their functions run. An example program which explains the global and the local variables. You can see here, main program, tigase is equal to 95, print tigase. So it will print 95, state 1, that means a function call. So the function definition will get activated. And what is there in that function definition? Tigase is equal to 15 and print tigase. Now the value of tigase is 15 and it will print 15. Again, coming back to the main program, print tigase. Since that tigase is equal to 15, that is confined within a function, it won't change the value of tigase outside the function. Again, the last statement print tigase will get the value 95 itself. Another example, defining the global variables and the local variables. Here you can see the main program. Tigase is equal to 95. Print tigase. It will print the value 95. State 1. That means a function is called. So the function definition. And what is written in the function definition? Global tigase. That means a variable is declared that is globally accepted. So now the value of tigase is equal to 15. Since that tiger is global, that 15 will be affected everywhere, not only within a function. Now print tigase. It will print the value 15. Now coming back to the main program. It is written the last statement print tigase. So which value it will print? 95 or 15? It will print the value 15. That means in this program the output will be 95, 15, 15. Changes in the immutable types are not reflected in the caller function at all. Changes, if any, in mutable types are reflected in caller function if its name is not assigned a different variable or data type, or in other words, are not reflected in the caller function if it is assigned a different variable or data type. Each and every point will be explained through the next video, a video which consists of examples related with the function.